So today we are privileged to have Dr. Kwame Agyekum, who will be doing the presentation today. Dr. Agyekum's topic for today will be enhancing fisheries management in the Gulf of Guinea, leveraging EO data for sustainable practice. We chose this, or we proposed this topic to Dr. Agyekum because it utilizes EO data to monitor fishing activities, uses EO data to identify potential fishing zones, and then also uses EO data integrated for policy making. So this is very critical for the program that we are running under GAIAthon 2025. It provides practical application of EO data. Dr. Agyekum is a lecturer at the University of Ghana and also serves as project manager for the Global Monitoring for Environment and Security Africa Marine and Coastal Areas Management for the North and West Africa. Dr. Agyekum's work focuses on the use of marine EO data to support fisheries management, maritime security, and safety. At the University of Ghana, he leads efforts to develop coastal and marine services that aid monitoring, control, and surveillance in the fight against illegal, unreported, and unregulated fishing along the west coast of Africa. And Dr. Agyekum combines satellite data, numerical models, in situ observations, and AIS vessel tracking to produce tools to help manage the resources of our ocean. Distinguished ladies and gentlemen, it's my honor to welcome Dr. Kwame Agyekum as our third webinar speaker. Dr. Agyekum, you have the floor, sir.
All right. Thank you, Professor Yafi. I guess I can be heard loud and clear.
We can hear you, sir.
Perfect. All right. So, colleagues, friends, it's glad I'm excited to be here today and to speak on the topic that Prof just introduced. Just like Prof Yafi had indicated, I work at the University of Ghana and I coordinate this project from the university. I work with other partners. There are some based in Morocco, Cote d'Ivoire, Benin, Tunisia, Nigeria, Ghana, and Senegal. What we do here is basically take satellite data, some in-situ data, and develop various services which I would discuss and explain, and perhaps point you to what you may be required to do in developing your project as we proceed through GAIAthon and GAIAfest. My presentation will look at these three key points. Basically, I will try to point you to how EO data can be transformed to support the monitoring of fishing activities and detect illegal activities at sea. How we use model products to produce potential fishing zone maps, which we find very useful for protecting ocean resources, largely, marine living resources. Then we would also briefly discuss how EO data is crucial for policy and decision making in our quest to ensure that our ocean is sustainable and the resources we have in there can stay in for a very long period of time to support our livelihoods and so forth. So I will start by pointing us to our ocean and the sort of challenges that we have. I know in most parts of West Africa, our oceans are not as clean as we would have loved it to be, largely because there's a lot of this transport of litter and debris, mostly from land-based sources through rivers to the coast and to the ocean. This has a lot of implications for the survival of certain species of marine living resources, especially turtles. Some fishes also sometimes feed on plastics and litter, and when that happens, they sometimes have their intestines. And can you see my screen, please? Are you able to see my screen?
Yes, you can see it.
Okay, sure. All right. So they have their elementary canals clogged, and it's not the best. The next picture I'm showing you is it looks like a brown turf, but then that is sargassum, that is beached. So macroalgae, when they grow uncontrollably within the ocean and or within our seas, can get beached, and they sort of don't make our beaches very cool to visit. When they rot, they generate a terrible stench, which isn't pleasing at all. So the point I'm trying to make is these sort of activities at sea and the sort of debris that we get beached tend to affect how well we can use the beach area for recreation and for tourism. There's also fishermen who use the ocean as the main source of livelihoods. They go to sea, they get fish, they sell them, they have to take care of their families from the sale of these the resources they get from the ocean. At sea, we also sometimes have very huge vessels that fishing vessels that go to fish, and they transfer their catch to other fishes and they land them elsewhere. So that stops countries that are supposed to benefit from the sale of those fish from making money. This is one aspect of IEU that we have developed some services to help reduce. Then we have issues related to petroling and so forth. Then there is also environmental issues at sea with respect to discharge of oil or accidental spillage of oil. How do we ensure that we have information on all of these infractions or these environmental challenges? Satellite is one of the ways to go. So in my presentation, I would try to point you to what we have done so far and how we can bring Earth observation data and Internet of Things to improve on how we can monitor the ocean, understand ocean processes, and see how man is impacted in the ocean and how we have to build solutions using these sources of information for to improve our lives at sea. So we all know that yes, there are a lot of satellite data out there, largely a lot of microwave, that is radar images. There are optical data sets, there are thermal data sets. All of these, when combined, helps us to understand different aspects of the ocean. Now, the use of IoT has also been, spoken about largely recently, and the reason is very simple. Now there is easy internet access, and there are a lot of sensors that we need to get connected to each other. We need to be able to take information from remote sources, and IoT sensors provides us that opportunity. Because they are low cost and easy to set up, it has slowly become one of the go-to platforms for building solution. So it's one of the things that we can start thinking about to understand the ocean, to collect information within the ocean space, and build solutions around that. The other exciting thing about IoT and Earth observation is the fact that they are able to cover vast areas and they can collect a lot of data within a short period of time, meaning we are in a very good position to collect significant amount of data that can help us build solutions and sort of set up things that are connected to each other, and we are able to build platforms or applications that we can share information easily. So why do we want to look at EO and why Internet of Things? Like I had indicated earlier, we have a wide area monitoring with satellite. We can also continuously collect data at regular intervals. It allows us to build historical data, so we can build very effective models, because we would have long-term time series data sets to build our solutions around that. Internet of Things is also the way to go, because it allows us to have real-time data. We can also localize the data collections and get devices connected, so we can monitor various parameters from temperature, from salinity, from speed of currents, direction of currents, the altimetry, or the height of the ocean surface. All of these parameters that I have just mentioned are sort of some indicators of the heartbeat of the ocean, and it helps us to understand how the ocean is changing, and how all of these affect stuff like nutrient distribution, the distribution of organisms. You can even go further to understand some ecosystem interactions and ecological interactions between organisms. Again, by using EO and IoT, we will be able to collect high resolution data. We can have multispectral data. Here, what I mean is that satellites have different bands that look at different regions of the electromagnetic spectrum. And if you have platforms that can collect different aspects of the spectrum, you are in a good position to look at different features of the ocean, which allows you to understand different aspects of how the ocean is changing and how they impact certain processes within the ocean and the distribution of organisms. High frequency data collection and ground truthing abilities of IoT allow us to also improve how satellites are designed and the data that we collect. We can also, by using these tools, be able to, develop cost-effective and scalable solutions that we can transfer from one place to the other, or we can extend. By combining all of these, we are in a good position to make better decisions. So, colleagues, I think the decision that you have made to be part of this endeavor, this initiative, is very important, because now you are contributing to breaking certain boundaries. In the past, no one would think about how can you combine EO, IoT, and all of this. This platform or this initiative allows us to do that. So let's keep the momentum and come up with ideas that would help improve on how we can use technology in fisheries resource management. So at the University of Ghana, these are some of the services that we look at, from monitoring or forecasting ocean variables from satellite data or from models. We have a fisheries management service that allows us to map fishing grounds, report on illegal fishing activities. We have a safety at sea service that targets coastal communities and fishermen. We have services that allow us to look at coastal vegetation, shoreline erosion, and so forth. And we have also implemented a region-wide oil spill monitoring service, and I'll take you through some of them. So, with respect to our fishing mapping service, we basically are coming from the background that yes, we have a vast ocean. It's a very competitive area. There are different sizes of crafts that go to explore and exploit fish. But then, how do you ensure that with little resources, people who are mandated to protect marine living resources would have an idea of where fishermen are likely to go to fish? So we use a model products that look at temperature, salinity, currents, and other processes within the ocean to understand where fishing vessels go to. So by analyzing AI's data, which is vessel traffic data, we are able to tease out fishing grounds, and we extract the environmental conditions from the model product for those fishing grounds, and build a structured data set that allow us to look at the distribution or where we had found fishing vessels that were fishing and the conditions there. Now, we put all of this out and build a model around that. So we look at the nonlinear relationships between the environmental conditions and the presence of fish, and we are able to forecast by providing the model with input environmental data that allow us to predict fishing grounds. So the image you see here shows the data set to validate the fishing grounds, we extracting the data, building a model, and we have an output that shows fishing grounds. So this information we share with only people with national mandates to police the ocean, the Navy, Coast Guard, and so forth. And the idea is when they have this chart, it's geo-referenced, they can know the locations where there's optimal conditions for fishes to aggregate, and that's where they need to intensify policing. Then this is our safety at sea service, which we disseminate via a mobile USSD code or a mobile app or the use of flags. So we look at ocean states from incept products, model products, and we look at stuff like wind speed, the height of the waves, and the speed of currents. We put all of these suite of parameters together, and we come up with certain indices that sort of are related to how calm or how rough the ocean is. Now, when we generate the indices, we share this. We can generate 3 days ahead of time, and we make this available to fishermen. The interesting thing is that it's not just fishermen who use the service now. Even their wives, who often own the canoes, they also use the service. So before their husbands set out to sea, their wives can also check: is it safe for my husband to set out and go fish? So this service has been very, very useful. It's widely used in Ghana. We are pushing it to Nigeria, some parts of Gambia, and Senegal. Then we also have our ship detection service. So this is a platform. It's a web platform that houses 3 services: our oil spill, our ship detection, and our transshipment monitoring service. And I'm going to take you through them. So basically, the idea is we don't want to burden our partners and our users in West and North Africa with processing satellite data. I mean, there's a lot of data available, but then these data sets are so huge. They come very often. There are a lot of satellites, so they are constantly taking images, and processing them can be cumbersome using your normal laptop or desktop CPU. So what we have been able to do is we've optimized some processing codes that allow us to quickly detect the spills and the ships, and we disseminate the information via this web application. So this application is a bit restricted. It's only designed for people involved in environmental monitoring, those involved in maritime security and safety. So, but the reason why I'm showing you this application is these are some of the things that we need you to start looking at. You need to look at issues within the ocean space or within the coastal environment, and you need to build tools around that. So, for instance, the information that I'm sharing here, how perhaps can you improve it with maybe a chatbot on how to communicate or report the detections that I'm going to speak to you about from here. So from this platform, you can see ships that we have detected from satellite. So sometimes some vessels don't show their location. So when you have this application, you can clearly point out vessels that are present when the satellite passed. And if you are not reporting your location by comparing this data sets with AIS data or any vessel traffic information, we are able to identify dark vessels, and you can report that. We also have the oil spill detection service. If you look closely, you can see some dark patches in the image. Those are detected spills. Now, we can query by date, by area, by certain coordinates, and you will be able to filter detect spills that may have occurred within a particular part of the ocean. Now, on the application, you can click on a detection, and you have extra information on when the detection was observed by the satellite, the location of the spill, the size of the spill, and so forth. One of the things that we are working on is we are also going to include a dissipation model. So when you click on a spill and you provide certain information to an additional tool that we would add, it would give you a fair idea where the spill will travel to in some space of time. So these are the things we need you to start thinking through. How can you bring innovations in the things we do? Then we also have our transshipment service. How this service allows us to find vessels that had come close together, fishing vessels that had come close together for a long period of time within the ocean or offshore. So we are able to identify and further investigate potential fishing infractions. So in the past, we had thought about tracking small vessels, that is canoes and semi-industrial boats. These are largely used by artisanal fishermen. And in most monitoring systems, these ocean-going platforms are not monitored electronically. But then I think we need to look at them. So I think about 7-8 years back, we put some Class B transponders, those things you see in orange on the boat. We were able to even power them using solar panels, and we're able to understand how far they go, how they behave at sea. Now, in that example, we had used a device that is out on the market. It's a commercial device, very expensive, but then we're only able to track their positions. But then for us as scientists and people who develop the solutions I've shown you earlier, we need in situ data. So we tried an idea where using Arduino board, some temperature sensors, a GPS, and some batteries and solar panels, we were able to put a temperature sensor with a GPS, and we could track a small canoe, the canoe you see on your right. Just beneath the base of the canoe, you can see some wood, a small plank of wood sticking out. Just behind that, we have the temperature sensor. So at any point in time when the canoe is in water, we could collect data, and that is very exciting. So for me, one of the things I need you guys to think about as you try to develop your solutions is that, one, we need to speed up how fast we can process data. We should also recognize the fact that because we are using satellite data, IoT sensors, data will come in large quantities in different forms, and it's going to come very fast. We need to have solutions. Think of innovative ways of processing these data and visualizing them quickly, because that is what will allow your users to find your solutions exciting, and that will make you win the prize that we are all hoping to to win at the end of this activity. So guys, think through this. What are the ways to better visualize, process data fast, and communicate the tools that you want? So going forward, I will quickly point you to some of the things that you need to start thinking about. And I'm sure Professor Yafi will share the slides with you, so you can always consult and pick some ideas from here. So within the coastal and inland water space, you must start thinking of solutions that can allow you to look at coastal vegetation. Within the coast, there are a lot of mangroves. Mangroves are very, very important in ensuring that there are breeding grounds for fishes, some kind of fishes. So it is important we can track them. We also need to know the health of mangroves. So you can use thermal images from satellite, or you can improvise something, or you can even have a balloon mounted with a thermal sensor and image within a small space how the vegetation there are faring. You can also assess carbon stocks. Mangroves are huge storage centers for carbon that we assimilate from the atmosphere. It's important we are able to assess them. So, again, you can also track how plants are changing over some period of time. Satellite data can help you do that. You can also do some habitat fragmentation analysis by looking at various satellite data sets You can run an NDVI analysis, do some clustering, and put the different habitats or types of vegetation within the ocean space. Now, what a lot of satellite companies love is ground truth data. You can start thinking of ways of having an application where you can take a picture and you can share it with a company that has some satellite in space. In terms of water quality, we love to use satellite. In our part of the world, it's a bit difficult to do that because we live in a tropical region where we have a lot of clouds. But then in some parts of the world where they have a lot of clear skies, you can look at harmful algal blooms, sediment distribution with satellites, and it's something you can look at. You can also think of developing tools or sensors that allow us to collect water quality parameters, how turbid is the water, what is the color of the sediment that is suspended in the water column. All of these will allow us to improve the quality of water that that we find around our coast and how well fishes will thrive within these water systems. We can also be looking at some maritime application in terms of, like I had explained, improving our fishing grounds, developing tools that can improve maritime surveillance, developing tools that can allow us to do better shoreline monitoring. Because I know one of the tools most scientists use is video cameras. You can think of developing a very small kit that you can mount at different places at different times for some period of time, collected a lot of data. You can analyze that, and you can have a better understanding of how the morphology of the coastline is changing over time. We can go ahead and improve our oil spill detection with better dissipation tools, which will allow us to better manage the ocean space. So going forward, start also thinking of early warning tools to provide better alerts. It could be even earthquakes. Start thinking of all of these things, because when we have such tools, we can better have ways of protecting ourselves and decreasing loss of lives. So for me, just as I try to wrap up, at the end of the day, there are decision makers who want solutions, and see yourselves as people who can help these people who don't have time to be reading large documents. They need information to plan. You should be able to provide them what they would need to support what they do and ensure that yes, humanity always survives. So going forward, anytime you build a solution, first think of who's going to use it. So most of the time, your users, which would often include policymakers, have ways of building things that will work for them. Make sure that the tools you develop for them are not so difficult to use. It would allow any low-level person to be able to understand what you are generating. So this will be the end of my presentation. You can always reach out and see what we do on these social media handles. And thank you very much.
Thank you very much, Dr. Agyekum, for your insightful presentation, which lays the ground for our GAIAthonians to begin thinking of some of the solutions that institutions like yours are looking for. And I believe that the questions that they will be asking you will also help them to think through how they can improve upon what they plan to do. So without taking too much time, I will request that you moderate the question time as they ask you the questions, and also to look at the chat page if there are any questions also from there. So please ask your questions. Please can you unmute and then ask your questions? Normally, when we are getting to the end, then a lot of questions start coming. We have enough time to be asking questions. Go ahead, please.
Hello, good morning.
Hello, good morning.
So, can you come back just a little time in French?
Can you please repeat what you just said?
I say, if it's possible to come back in French, you translated that in French just a little time.
Sorry about that. I don't speak French, but I guess there could be some transcript, French transcript.
Yes,
later.
with the by pushing
Okay.
this to the YouTube, it's possible to get some captions in French. Our subsequent presentations, some of them will come in direct French, as I indicated at the first day. So apologies. Maybe in the future we'll do a dual translation with the presentation. Dr. Agyekum, just a question from my end, maybe that the students can be thinking about. You've developed some of these solutions, but as your institution thought about including APIs from maybe OpenAI and DeepSeek to sort of augment some of the responses that your apps can provide users?
All right, thank you very much. I think on one of the slides I indicated that we need to improve on how we provide responses on some of the things that we detect, and I think AI is the way to go. So now there are a lot of AI agents that people can build solutions around. So I would advise that after today, colleagues, you can start thinking about what these applications or tools can allow you to do. It will be very exciting to have an agentic AI that would translate some data or some metrics into some language that I can't even express myself on. It will be very exciting to see automatic alerts coming from AI warning you about some extreme rainfall that is you would expect in maybe 4 or 5 hours. So these are some of the things I guess you need to start thinking about on developing in developing your solutions. Thank you. So is it okay if I read some of the questions that I have from the chat?
Please go ahead, sir.
So there's a question from Felix, and he's asking, how do you let the public know of your platforms, and how would you know the credibility of their profession when in need of your web access? Yes, thank you for that question. So the applications that I showed you, those ones, it's restricted, and you have to provide some details about yourself. That would allow us to know whether you have the right expertise to use the application that we develop. It also allows us to do some background checks on you before we assign you access to the application. With respect to how do we let the public know about what we do? Yes, we have social media handles. So that's one way of reaching out to people on what we do. We also have some community of practice. There are people within who are within a specific discipline or unit that have access to our service. So, for instance, we have fishermen who would ask for our safety at sea service. We have a Ghana Meteorological Agency that supports our marine meteorological services, and they also can reach out to different people from different countries. So that is how we try to reach out so that people can know about what we do. So there's a question from Jerome, and it's, when are you starting VMS and EMS? So when it's always a national activity, or it's more like a national project. But then I guess the point you are asking is, are we open to have some IoT driven VMS or electronic monitoring system? We are very much open to that. There is a huge need for that. So please think about that. And if you want us to discuss it, I'm very, very open to support some of the things you want to work on, right? To guide you in developing them and taking through the solutions. Then there is a hand up, Nian. So Nian, you can unmute yourself and ask your question.
Okay. Good morning, Kwame, George, and all the vice present. Yes, I want just to help some of the Francophone speakers that in the text that are submitted, even the last presentation, if you see traduire, if you click on the traduire, you can get the text in French. You can also use other tools like DeepSeek, Claude, OpenAI for the translation. It may not be perfect, but you will get most of the ideas. Voilà, ce que je voulais dire à ceux qui parlent français, au-delà des traductions rapides éphémères que vous avez, il y a des documents. Si les documents sont transmis, si vous cliquez sur traduire, vous avez une bonne traduction, plus ou moins de documents. Mais aussi, si vous utilisez DeepSeek, le truc chinois là, ou bien OpenAI, ou bien Claude, il y a beaucoup d'outils maintenant. Quand vous utilisez, vous demandez que je veux que le document soit transcrit en français. Là aussi, c'est possible. Donc, vous pouvez le faire en attendant, bien sûr, que tous les petits détails là soient réglés. C'est ce que je voulais dire. Okay, thank you all. I want just to make to give some insights that people can, use some tools to understand the idea. But the document itself, you can see on the document traduire. If you see traduire, when you click on it, you will get it on French. Okay, thank you, man.
Thank you very much, Dr. Nian. So there's a question on me listing or pointing you to some EO sensors that you can work with. Yes, so there are lots of them. I mean, I don't think I would be able to go through all of them. But then within the Copernicus program, we have the Sentinel suite of sensors. So there's Sentinel-1 for radar imaging. Then there is Sentinel-2, which has a land sea temperature sensor. It also has an optical sensor for looking at vegetation on land and within coastal areas. We have Sentinel-3, which has a temperature sensor for ocean applications and an optical sensor for ocean applications. Beyond that, there are other radar sensors from RadarSat. We have ALOS Parser, Cosmos SkyMed, there is Tandem X. When we look at Altimetry, we have JSON. There are some of the Sentinel suite of sensors that also look at altimetry. When we look at temperature or rain, there's streams. So just go out there, Google, and trust me, you're going to find a lot. If you go to EO browser, or if you Google EO browser, it should point you to a platform for accessing data. There's also Copernicus data space. Please Google some of these things and you would find the sensors. Or perhaps maybe we can put a link somewhere on the website for you to access some of these data sets for your applications. Then there's Iman Obedi is asking, you mentioned IoT and data from canoes and ships. How is this data secured? Could an intruder tamper with it? I'm particularly concerned about data security in such scenarios. Thank you, Emmanuel. I mean, that is one thing you can develop a solution around. I clearly understand that when in data transmission, if you don't put a lot of securities in place, the data can be spoofed and so forth. I think it's a good point you've made. I don't do that, but I agree it's something that we have a need for that. So if you can build a solution around that, you are very much welcome. There is a question from Max. With building our project, should we also focus on the risks analysis like sensor failure and power outages? Perfect. I mean, these are the things we want to hear. So you are free to look at some of these challenges in with respect to data collection and ensuring that there is data availability at every point in time for a very good service in developing service and building operational services. These challenges we need to surmount them. So you are spot on. Thank you very much. There's a hand up. Nana Kwija, please unmute yourself and give us your comment or ask your question, please.
Yeah, thank you very much, Dr. Agyekum, and thank you for the presentation. Unfortunately, I couldn't join early, so I might have missed a great part of the presentation. But I am familiar with the work that GMES and Africa and Gaia project all are doing in this regard. And I'm happy about the topic on fisheries management. I am coming from the small-scale fisheries background, and for us, fishers' participation in data collection is imperative in fisheries management. In recent time, it has become more necessary to include fishers in data collection to support fisheries management. I don't know what you have said earlier on, but is there any package for small-scale fishers in terms of how we can participate in collecting data? Basic technologies that we can be supported with in data collection to support fisheries management. What is it? What is the plan? Anything in that regard? Thank you.
Thank you very much, Dana. I'm excited with your thinking. I mean, it's fulfilling to hear you as a fisherman wanting to be part of an initiative that allows us to collect data. And through our engagements over the years, we've realized that having the right data sets that is tied to fishing is very important in improving our ability to manage the ocean space. So one of the slides that I showed shows how we can put different sensors or build solutions that will allow us to collect different kinds of data sets. In that example, I showed a canoe which had mounted on it a temperature sensor that is connected to data transmitter called LoRa, and it will allow us to transfer data collect in situ in real time to any web portal or a data receiving application over the web, and we can visualize and process the data. So we have started some initiatives, and I'm hoping that our colleagues here and friends here will be building solutions, and they can perhaps even engage you and bring you on board to point them to exactly what a fisherman would need, so that we will be able to build solutions. But at the various national levels, and speaking for Ghana, there are some interest in some of the things you are pointing out. I know that we are trying to build new canoes, and maybe going forward, it's something we can advise that we include sensors within or as part of the canoe building, so that right from the onset, as the canoes set out to go to sea, we can collect data, we can know where they are, because this is also very important for safety at sea. I mean, when you have these sensors on board, we can track their movement, and we can see where they go, and they can also report incidents that they find at sea. So thanks for the observation, and I think it's very laudable. Thank you so much. All right, there is Macho Tom. He says, it seems like I heard something about the language which the presentation should be delivered. Okay, you would get some French transcripts after the presentation. Any more questions, please? Are there more questions, please? Okay, there's a hand. Sam Laws.
Hi, Kwame. This is
Ah,
Rebecca Kills and Rebecca Samoa.
sure.
Yeah, thank you very much for the presentation. And I just got to know this on very short notice, but I'm glad I joined. As soon as I saw the information on the UG page, I pushed it to the Ghana Fisheries Alliance page, and I'm happy that Nana was able to join. Hi, Nana Kweja. And Nana speaking just reminded me of a discussion we've had a couple of weeks ago, and this is just for my education. With rising sea surface temperature, would we need any extra kind of information, or, as it were, added information that would help in bringing up the discussions on fishery stocks moving further away from the coast, and therefore helping us to define our fishing zones as we already have outlined in some of our regulations? Kwame.
Yes, thank you, Becky. So this problem you just pointed as to, we are unable to solve it properly because we don't have historical data. If we had historical data on ocean temperature levels, historical data on where canoe fishermen had operated and where they had caught fish, we would then be in a very good position to predict where stocks will move into. So the issue Nana brought up, if we are able to bring in technology to help us collect data, then we can perhaps be able to predict where stocks would go to, because let's face it, the ocean will not, the ocean is very dynamic and things will remain changing with time. So for us to be ahead of the game, we need to have systems in place that will allow us to collect data, that will allow us to forecast or predict some of these things that are so important for resource management and conservation. So perhaps, Becky, we need to sit and talk and see how we can push that agenda and get our canoes and other seagoing platforms fitted with sensors to collect lots of data for improved management. Yes, thank you. All right. There's a hand up, Dr. Nyan.
Kwame. Yeah, I wanted to share the application like UG I have it on one of my phones, but it's not anymore available on Play Store. And I open it now. There is no data being pushed on the like Ocean State
Okay.
on my phone. I don't know if there is a problem or something like that.
Okay.
Okay.
Yes, we reconfigured some of our stuff. So I think very soon that the data sets will be online to be accessed. But then we have a geo portal. So if you can't use the application, I guess we need to point you to the geo portal, and it's listed on at the end of my presentation. So you can always use the geo portal just in case the mobile application fails. Is that okay with you, Dr. Nyan?
Yeah, that's okay. That's okay. Thank you.
All right, sure. All right. Nana Kuya, your hand is up. You have the floor.
Thank you, Kwame. You know, this topic and the conversation is always interesting when we get opportunity like this too. Kwame, you may be aware of the annual close season that is organized in Ghana, and the inclusion of the artisanal fishery sector. And for some of us, it's a very unpopular policy, and it has not proven to be productive enough from my point of view and where I stand and for fishers and what we see. Now, with satellite imagery and the kind of technology and systems that we run, I would like to know the possibility of identifying very productive areas in the marine space that, for instance, if we will have to more or less like zone our space, and then from time to time we shift from one side to another side whilst we allow biological activity, whatever they may call it, to occur in those areas whilst fishers are not denied, and the entire access to the marine space. You will hear people citing example from other jurisdictions, but they tend to forget that in those other jurisdictions that they cite those examples, they are either the closure is either based on species or based on particular area. For instance, a Gulf area that is closed, but fishers have access to other spaces to fish, or it is in relation to particular species, and so you can fish for other species, and then like the Senegal case that people mention for the octopus, while fishers can fish for other species.
Nana,
Now,
if you could please wrap it up, because we have just 5 minutes to wrap up. And Kwame, I would like to make an intervention after Nana has spoken so that we stay within the objective of the GAIAthon.
Yeah,
That's fine.
so I'm asking of the possibility of identifying highly productive grounds within the marine space to inform how fishers can stay out of one particular area whilst we fish in other areas, and then to avoid the blanket closure that is implemented in Ghana. Thank you.
Yeah, so before Kwame, you come with your thoughts. Nana, this is the purpose of this webinar series, that the students from the 16 universities which are participating in this year's GAIAthon will come out with solutions to some of these problems. So this is right on point. And to those of you who want to develop solutions for the marine space, this is a renowned fisherman who is telling you about some of the problems they have at sea. And when you bring some of these solutions, just imagine the number of fishers who will be working with your solution. And Kwame, you can address this one with your wrap-up thoughts in 60 seconds, and then I'll do some housekeeping and we bring the curtain to a close.
Yes, I'll make it very quick because I have another meeting in 2 minutes. So Nana, yes, so protecting the ocean space when it comes to the distribution of fish it should be driven by science, and satellite is the way to go. We will be able to find productive areas from a lot of satellite data. One example is when you look at chlorophyll A or ocean color products, when we look at currents and winds, all of these we can combine them and we can be able to tease out which part of the ocean is very productive. Again, we can also even use the behavior of the fishing vessels. So if we track them and we know where they go, and we combine this with all the satellite data and sometimes some subsea or deep sea data sets, we have enough to help us know which parts of the ocean are very productive and why we need to protect them. So I'll make it very short. It's doable, and it has to be backed by science, and satellite and or geospatial tools provide us all that we need to be able to do that. Okay, so Prof, thank you for having me. I know we have to wrap up quickly because I need to join a meeting in 2-3 minutes. But then, just like Prof had said, this initiative should point you to what we want to achieve. We need to build solutions that is data driven, that will also solve problems. And just like Nana had pointed out, there's a huge need for the issues we are bringing up here, and we need scientists, technicians, computer scientists, and developers like you to help solve the technological challenges that we have in our world with respect to how we utilize our ocean space. So going forward, GMES Africa, McNoah project, we are very open to support what you do, and don't hesitate to reach out. Prof. Yafi, thank you for having me.
And thank you very much, Dr. Agyekum. And on behalf of all the participants of GAIAthon 2025, we express sincere gratitude for making time available to share some insights with the work that you are doing. 2 points, and then we close. Number one is that all the universities have registered and the teams have been formed. So if you are from any of these institutions and then you are not seeing on your side that your team has been approved, let us know, with the exception of Senegal. So it is only Senegal that we have a little issue. We have a lot of you students from Senegal who have registered, updated your profile, but you have not formed the teams. We have only 4 teams from Senegal. So please, as quickly as possible, those who have registered and are team leaders, bring your people together and then form your teams. Next, this coming Thursday is a very important day. You've been hearing about the GMES and Africa program. Actually, this is the program that is financing GAIAthon 2025. We have the team leader of the program coming to do presentation, and he will be the person to lead you into a lot of insights. So I will encourage all of you to log in on Thursday. The link is on the GAIAthon Hub website. And then same time, 10 o'clock GMT, we will have engineer Hamdi Kasim, who will be presenting to us. So on that note, ladies and gentlemen, thank you so much for being part of the webinar, GAIAthon webinar series, and stay well. Thank you very much. And we bring the curtain to a close.
Thank you very much. I'll see you on Thursday. Bye.
Right, bye.
Thank you, sir. Bye.